Let's say you have 3 friends and you have stored their ages in an array. And let's say your first friend just had a birthday. So what you want to do is you want to update his age from 20 to 21. And I've written this out here. So the way you could do this is you could take his first age, take the first age from this collection and then increment it and then assoc onto the ages collection and thereby override the first element with the correct age, which is now 21. And if we run this, this works. You see that the first element is now 21 instead of 20. And this works fine, but you may be able to see that if you were to do this every time you want to update something in a collection based on a value or depending on a value that's already in the collection, this could get a bit repetitive because you'd have to extract that value first every time and then assoc depending on that value. So it would be nice if we could write a function that extracts the value for us and then performs the assoc for us as well. Now in Clojure there exists such a function, and that function is called update. And we're going to try and re-implement it in JavaScript. Now the signature of update is going to be very similar to that of assoc. It's going to take an item and a key. But then instead of a value, it's going to take some function and some arbitrary number of additional arguments that we can pass to the function. I'm going to get into that in a moment. Now what we're going to do here is we're simply going to call assoc with the item and the key, because eventually we want to update that value at that key. But what do we update it with? Well, we're going to update it with the result of calling the function that we're given with the value at the key that we want to change. And then we're going to pass any additional arguments to that function that we were given. So this may be a bit much to digest all in one go. So let's look at an example. Let's say we want to write what we wrote here using update. We want to increment the first item in the collection. This would be very simple using update. We would simply say update ages at index 0 inc. That's all there is to it. Let's make sure that this returns the same thing, and it does. So what does this do? Well, it passes in ages as the item, 0 as the key, and inc as the function, and we're not passing in any additional arguments. And then what it does is it calls assoc on the item and that key, and it's going to overwrite the value at that key with the result of calling inc on 20, because getting the item at index 0 is 20. Now another thing we could do to illustrate what this additional argument list does is we could call update on the ages again and say, you know what, we forgot that our third friend, he actually had 10 birthdays in a row and we've forgotten to update his age this whole time. So instead of just incrementing his value, we actually have to add 10 to that value. So how would we do this? Well, we would say plus 10. And the reason this works is because underneath the hood, it's going to call plus 4010. Because remember, the first thing that the function plus is going to be given is the item at that index, the value at that index, I should say. The value at index 2 is 40. So that's why it ends up as the first item here. And then any additional arguments we pass to the update function right here, well, those just get passed along to the function that we passed in right here. So that's how this number 10 ends up here. And that is how the last value in the collection is now 50 instead of 40. Now you could imagine yourself performing multiple updates like this in a row, and it would be cumbersome to store every intermediate result in a new variable. So instead of doing this, we can now combine this with our thread first operator. Why the thread first operator and not the thread last operator? Because as you can see, the item we're passing to update is the first parameter to update, not the last one. And it's the same for assoc. So let's see if we can make multiple changes to our ages collection in a row. So let's say the first thing we want to do is update the first age and increment it because our friend just had a birthday. Let's say we want to update our third friend and increase his age by 10 because we've been forgetting to increase his age for the past 10 years. And let's say we also want to associate, we want to override completely the second value because we just made a mistake. That friend is actually 50. And so let's run this, make sure everything's correct. And I think this looks good. Our first friend, we incremented by 1. Our second friend, we incremented by... No, our third friend, we did the third one first. We incremented by 10. And our second friend, we simply overrode with 50. So there you have it. This shows that using a combination of a thread operator and update and assoc, you can make successive changes to the same data structure without any mutation and legibly in order. I like to think this is a very nice design pattern that we were able to re-implement here from Clojure. So if you were to decide one day to take a look at Clojure, and I'm sure that you will find code very similar to this, and you will know what it means.